Well, hello Internet of People. We haven't made a video recently because we were developing and testing a lot. We managed to implement a decentralized identity system on the Hydra core, and we were testing it on the testnet, and soon we will publish it on the devnet for developers to start writing applications on top of it. We also, in the meanwhile, created some sample applications so that we show example how to use this solution and our SDKs in order so that you can integrate it into your application. But let's start with the basics. If you haven't checked our Prometheus demo, we have it on the YouTube channel for a while now, and there I explain that you can create different personas for different roles in your life, because we think that you don't need to attach all these different roles in your life into a single identity. This improves privacy and helps you manage your social life as it was before the internet happened. So we made a specification and the documentation of these things, and let's start reading it. We will run through use case, which is someone creates a digitalized version of their ID card. They get it verified by an authority, let's say a government agency or a third-party authority that is trusted by many people in your society or city. And some service provider, let's say a local swimming pool, gives you discount if you are living in the same district. But you don't want to show your name, your I don't know, social security number or any other thing from the ID card, only the district of your residence. So the user is able to create a claim about one of their personas, which is basically filling out all the fields from the ID card. They will send it to this authority for witnessing it. They will provide some evidence that is needed by that authority, like they will make a photo of their ID card and they will show that they are the same person who sent in this ID card, that who owns the ID card. You know, this is a general thing in the know your customer business, to take a photo together with the ID card. And then the authority receives this witness request, checks it, and if they approve it, you can download a statement, which is basically a signed, stamped version of your digital ID card without the evidence, any evidence that was attached to these claims. And now you can use these signed, verified claims with the swimming pool to mask out all the data without affecting the cryptographic evidence, and you just show the district and then you get the discount. Basically, that's the use case that I will show you. You can check our specification. You can ask questions if you are missing some data from or information from this. Now I will show you 3 applications. Most of the source code is on Internet of People Morpheus TS, which is all the TypeScript code that we have now. But the most important part, the cryptographic calculations and whatever holds your private keys, is written in a safe language called Rust, and those you will find those source code under Morpheus Rust. So let's get started. We made a command line application as part of the SDK. It's in the Morpheus TS packages examples folder. I have it already checked out, compiled, so that it doesn't take more time from you. And I have it here. And now I will create 2 personas using this tool. This is a command line tool. You just start it up. You have basically a menu to go through. Now I will create a vault, which is first I choose vault and then I choose init, and it will save it under the file system. This is basically like initializing the wallet in the Prometheus app. It just doesn't have the fancy UI. But I will need for this demonstration 2 personas, so I will create another one. I can shortcut to the Vault submenu by entering it on the command line, and then I create the ID. And to summarize, now we have these 2 keys. Okay, a small detour here. In the IOP stack, we use multi-cipher, and these keys are basically, or these strings are basically key IDs, which are similar to fingerprints of RSA keys or Bitcoin addresses. So these are the hashes. These are related to the hashes of some public key. And you can check more about this in the documentation, in the glossary about multi-cipher. So anything that will start with a lowercase p is a public key. Any case with a lowercase I is a hash of a public key, so key identifier. Signatures will be there, and the next character, the second character, is related to what kind of cryptography we are using. And by default, we use ED25519, which is quite popular. It's also used in SSH or other places. And there are some other variants like SCP-256-K1, which is used by the Hydra blockchain or Bitcoin. And you can, the third letter, this Z, comes from us using multi-base encoding, and this lowercase z just means that it's a Bitcoin base 58 encoded string of some binary number. So if you decode this as base 58, then you get back the hash of a public key. So now we have 2 keys in our wallet. We can now check corresponding digital identity. So what does the blockchain know about this identity? We just created it, so probably nothing. Also, I just reset today the testnet, so there's no transactions there. But we can check. We should query rights on the testnet. And if you see this part of a DID URL, so digital identity URL conforming to W3C standards, and this part of a key ID is the same. So we just create a default DID document for anything that the blockchain hasn't seen yet. And this is similar to a Bitcoin address when no one sent anything to that Bitcoin address. You can query its balance and it will be 0. Here the 0 is that this digital identity is managed by this key pair with this identifier. It is valid at the moment, this key on it, and it has impersonation rights, so it can sign stuff in the name of. So this key can sign things or authenticate this DID document, and it can update this DID document on the blockchain. This is important because you can add new keys to your DID document and revoke old keys. Also, you can add the rights to those keys. And this is similar to a BGP key server. It's just on a blockchain where you can regularly replace your keys. So when they get out of date or you want to replace the cryptography to some other thing that we support in the future, you will be able to. Also, it's good for rights management. So this document can also be something different from a persona. It could be a role in a company, like, I don't know, a dean of a university, or it could be a group that has some right management needs. And all these things could be, all these entities could be managed on the blockchain without revealing what they are in real life. So getting back to add the new key to the document and to add some right, we need to spend some Hydras on this testnet. But for that I need some money on an address. So I will transfer some from the Genesis wallet. Yeah, I won't show you the Genesis keys for now, but so if you have some Hydras, you can send it to someone else, right? And by default, this script will send, let's say, 100 Hydras. So I sent in this transaction, and this will have a balance soon. If you see, so you can check it in the desktop wallet as well. This is the Genesis wallet that I sent money from, and this is the gas account that I sent it to. So now if I refresh the balance, there's a bug in the 2.8 Arc desktop wallet, but it arrived. This 100 test Hydras arrived to this address. So I can use it now for signing the layer 1 transactions on the blockchain. And these layer 1 transactions will contain, oh, the money has just arrived, so the bug might be even fixed on the desktop wallet. Good. So we send in some layer 1 transaction, and when it is forged into a block, then and it's already confirmed by the delegates, then we build some layer 2 state from these transactions. So that's what I will show you. So the next step is to add a key. So on the testnet, we add the new key. This is the did that we will modify. Okay, we will add the second key to it. Good. It will be valid indefinitely. We could also set a hate when it auto expires from the document, but I don't use that feature now. Then I have to use the first key to sign this transaction, because that's the only one, the implicit, the default key in the implicit document that has the right to update this did. Okay, and now I need to use the wallet, so the Hydra passphrase. Okay, it sent in the transaction to the node, and it's waiting for being confirmed. Okay, that was fast, right? We have an 12-second block time, and usually the first block will contain this, and then you will see this layer 2 processing has already succeeded. It wasn't rejected, so it was accepted. If I send in some invalid transaction, like here I try to add this key again, then there's a really important thing to notice. Layer 1 doesn't care about the validity of the transaction. It's intentional. So in order to avoid spam on the network, we on the layer 1, on the financial layer, we accept any transactions. It's like after the Byzantine fork on Ethereum, it accepts any transactions in, and then the smart contract calls will be rejected after you already spent the gas on the transaction. So we sent in the transaction and it has failed. Okay, how does it look on the Explorer? Because we do have an Explorer for that. So in test.hydra.iop.global, I can check the latest transactions, and these are the two transactions. This is the address of the sender, and it's important to know that there's no relation at all with the gas address and the did keys. So I could use any address to send in this transaction. And this first transaction was confirmed, and the second one rejected. And you can also list that this was an add key operation that was signed on layer 2. Okay, so getting back, we can now add some right to that key. Of course, because these are, sorry, so I would like to add some right. Okay, to this key. And I would like to add update right to it. And I have to sign it with the first keys because that's the only one having rights yet. Okay, I send it in. Probably it will be successful. And now I can revoke the default key or the impersonation right of the default key. Just the right, sorry. So I would like to revoke on this the document. Yeah, I would like to revoke the update rights of that key, and I would like to sign it using this key. Important thing to notice: you cannot use this. You cannot add or remove rights to that key that you are using to update. This is important so that you don't lock yourself out. Good, it has succeeded. As you see, it's quite snappy, so it just works. And if I now check, these are those successful transactions that we sent in. Good. Now, after all these changes, we need to have a look at, okay, how does this did document look like? So we're still on the testnet. We still care about this document. Haha! Things happened. So now we have two keys added. One was added at this height, so it wasn't present before that block height, and the key 0 has impersonation rights still. Also, key 1 has impersonation rights. Now this update right has been revoked from key 0 at this height, but key 1 is still valid. And if you want to, you can just have a look at this document. It contains the full history up until to a given query height. So this is the last state that it has seen, and therefore nothing is visible until after that in the history. But up until to that point, you can query anything client side after getting this document. Okay, there's this tombstone flag. You can freeze, so you can close down the document. That cannot. You can just not delete it from the blockchain, of course, because that is not possible on a blockchain. But you can revoke all rights from all keys at a given point, and that's what we call tombstoning. Yeah. So summarizing, we could add and remove rights to the document, and we now understand how this the document looks like. There are some future ideas that we would like to add to this document, but it's already quite usable. On the SDK, you can query whether a key had update rights or impersonation rights at a given height. Now that I showed you the backend part, we implemented some front-end applications to show you how to use our backend. We used Flutter to develop a mobile application because with the same code base we could use support Android, iPhone, Fuchsia, Macintosh, Windows, Linux. Dart has a virtual machine pretty much like C# or Java has, and Google works quite hard on providing an easy developer experience for front-end developers with Flutter. This MVP is missing most of the Prometheus functionality. We haven't meant it to be a complete application. We just wanted to show you how we imagine this whole backend to be used. So no wallet integration yet, and as I showed, that's why I showed you the command line applications to send in Morpheus transactions for key management. So our main focus was developing the platform, not the applications on it, and that's why we haven't spent too much effort yet on the customer experience. Still, I think this demo will put the icing on the cake, so you will better understand how to use personas, what are these claims, and how authorities or Web of Trust comes into the picture. So I pre-installed the two applications on this virtual mobile phone. I started the user application now. This will probably be integrated into the Prometheus application we have, or the Prometheus will be integrated into this one. We'll see how it goes. You can scan a QR code to connect to a given authority service with this application, but to save some hassles, we are running a small test authority on the cloud, and that's what you can connect to with this emulator menu item. This application downloads given processes, claim witnessing processes, and the definitions of them from that authority. Now I will choose the digitalized ID card, and it downloaded all the required schemas for the claim. So what kind of fields the claim has. It has the resident address, place of birth, date of birth, and what kind of evidence this authority requires. Right now it's just a photo, a selfie of you with a ID card in your hand. So let's start with this now. I will fill in Berlin, Germany, because I don't think it does matter what I'm filling in at the moment. Okay, I choose a date, let's say this one, continue, and now this emulator only uses a virtual camera, so I take a photo of this green box. Hopefully it will be accepted as evidence for my claim. Okay, and now I choose a key that can sign in the name of this persona. We have two keys, both have impersonation rights on this deed, so I just choose the first one. I can review the data on the claim once more. I can check the evidence I provide. This is only used during this process, and when the statement is created by the authority, it will be forgotten. So I now sign, and I wait for the results. Meanwhile, I change hats and start the witness application. So if I was a clerk or officer at that authority, I would check my incoming requests. I already rejected and accepted one, and this is something I have to work on yet. So I check, hey, this guy requested something, these are the data, this is the evidence, yeah, I check them all, pretend that, and now I approve it. So as a clerk, I also have a key which has a impersonation rights on this authority. We didn't deal too much with the workflow of the authority. This is just a small demo. All clerks are the same at this authority, and all the requests have the same priority. Obviously, this is in real life. Doesn't happen like that. Usually, these third parties have their own workflow set up anyways, and with our SDK, they can integrate many of these things that I show you here in this mobile application into their existing applications. So they can have their own roles, groups, right management, whatever these companies used to have. Yeah. So now I approve it with that key, and it is already approved. Good. So if I review this, the request inbox, everything is already decided, so I don't have anything to do. Now I go back, take back my user hat, and I can't wait checking what happened to my request. And here you have it. It's approved. Awesome. Now, in this simple setup, we gave 1 year validity to this statement, and we didn't do too much fancy UI to show what is in here. Still, you are a software developer, you can check what kind of JSON documents we are sending back and forth. I'm really hope you will be impressed by the possibilities of what this can do in your application. So anytime the user loses this statement, they can start re-requesting it. If it's the same request with the same nonce, they can get back to the same capability link. You will check the specification about this in the documentation. So the SDK, Morpheus SDK, has it all set up how it works. For now, let it be enough that we are still missing some tool to present this claim to the swimming pool, which lets you hide the date of birth, lets you hide the place of birth, and just leaves in parts of the address. And now this is interesting because you can hide this information, so you do not reveal this information. Still, the inspector can check whether this was really not tampered with, since it was signed by the authority. So this is pretty much like a Merkle tree on light wallets. You can just hide parts of it, of this document. Getting back, what is left to do for us? So this presentation, creating presentation in user tool, an inspection tool. Now, creating an inspection tool is quite use case specific. So for the swimming pool, you can decide, for example, if you want to integrate our SDK into the existing point of sale system, so that in the point of sale system you can use an NFC card or a QR code to to prove these, to get these presentations to the point of sale system, or you can have a separate mobile application scanning the QR code, and then you just the cashier just manually enters the discount based on what they see on the screen. We have decentralized right management, so IAM, on the blockchain already, but we plan to allow application developers to register their own rights and roles to keys on a DID, so they can, in the near future, you can not only update and impersonate DIDs, but you can make your own different rights, and keys can be assigned those rights. Good. In closing, We are testing this for a while now on the testnet, and we will soon update the devnet. The date of update, mandatory update will come soon in our Discord channel. It's a great idea to join our Discord. On the IOP Global page, you will see how to contact us. So at the bottom of the screen, you see our community, and on this page at the end we have many social media presence. If you are a developer, you are better off joining our Discord channel and watch our repositories on GitHub. This developer DevNet release will allow you to test your own applications that you develop using our SDKs, and will include all the updates from the ARC guys that they made from 2.5.9 until 2.6.1. It's a great release they had. They worked a lot during the Christmas. Shout out to them. And our Morpheus plugin is just a plugin on top of it. It creates a layer 2 state on the ARC code base. So we are not that far off the ARC blockchain code base. We cooperate with them and thank them for implementing this dApps system. That was all for now. Feel free to give feedback on TypeScript, Rust, and Dart SDK, and see you later.